This time we have 3 input NOR gate. Again, we're supposed to look at each waveform and draw the dashed lines at any change, any transition from low to high or high to low. So I have 2 transitions over here. Okay, waveform B has also 2 transitions. Okay, like this. And we have waveform C, which has also 2 transitions. Now we're supposed to look at each column, and please notice that we have logic 0 over here, logic 0 and logic 0. Look at this truth table. Someone is going to say, oh, we have 3 input NOR gate, but this truth table is only for 2 input NOR gate. But the concept is the same. No matter how many inputs you will have, okay, if all of them are going to receive 0, output is going to be 1. If at least one of them is going to have high, output is going to be 0. So we have all inputs receiving at this time 0. So when we have all zeros at the inputs, we are going to have high at the output. We have next column 1, 0, 0. If at least one of the inputs is high, output is going to be 0. That's why I'm going to write 0 over here. We have 1, 1, 0. If at least one of the input is having 1, output is going to be 0. The same story happens over here. We have 1, 1, 1. Any 1 gives me 0 at the output. We have 0, 1, 1. Again, any high at the any input gives me 0 at the output. And I have 0, 0, 1 again. If I have at least one high at the inputs, output is going to be 0. Next we have 0, 0, 0. When we have zeros at the inputs, output is going to be high. Now I can draw the output waveform. Okay, we have zeros over here, and we have 1 over here. And I can say that this output waveform is the solution to my problem.